Hey everybody, how's it going? Today we're working on my video editor. So the pitch is I stream for fun, right? I'm doing this because I like coding and I feel like it's a good motivator to make sure that I'm like making progress at the right rate, stuff like that. And I take like the VODs from these streams and upload them to YouTube because why not, right? And part of me feels like there's a better format for YouTube. When I watch other streamers' YouTube content, I gravitate towards the shorter versions of the same thing, right? If they give me a 20-minute version or a 2-hour version of the same content, I'll probably watch the 20-minute one. And so I wanted to see if that is something that we can do with this type of content. I don't know if it cuts down very well, but when I was experimenting with it and trying, I popped open KDN Live, like a Linux video editor, and I was like, holy, it's going to take me like 4 hours to cut down a 2-hour VOD. And if like the point of this is really supposed to be motivate me to code, then like spending way more time on editing the video than writing the code, even 50-50 is like way too much of a split, right? So I'm like, well, what if we made some tooling to improve this process for me so that we could try it, right? We don't even need to know, maybe this won't go anywhere, but writing the editor is fun anyways, so it doesn't really hurt. And so the thought is, it would be kind of cool if we could generate a subtitle set for the video and like display that as a script in our video player. Like, so here, this is like a mock-up of a video player that I drew in some text. Here's like your typical video timeline at the bottom, and my video is on the left here. Here's me right here, and here is like the to-do on the right, and here's like my terminal over here. And my thought is we could put like a script on the right side, and you could clip based off the script. So you could like select chunks of text and say, this is what I want in the video. And my thought there is that I can probably skim words on paper much faster than I can skim like content by audio. So that's the thought. What we have right now is we have a video editor that can play back something. We got sound working yesterday. Pretty cool. And so this is just running in like an OpenGL window. So we have GLFW window initialized. We spawn OpenGL, we spawn some like FFmpeg. Sorry, I shouldn't say spawn. We like pull in OpenGL. We use an FFmpeg library. We extract frames from the video file that's passed in, and we feed them to our OpenGL shader, which converts like the YUV data to RGB, displays it. Great. But now we're getting into the part where it probably makes sense to the next features to add would probably be like seeking support and like progress of some form. And so I think it's time to pull in a GUI framework. And so today we want to drive a Rust GUI from Zig. And you might say, why the fuck would you do that? And I'd be like, yeah, that would be my first question too. And it's because I don't really want to pull in Rust here, to be honest. Like I've done a few projects in eGUI and I like it. But it does feel like something like Nuclear or IamGUI like would be a better fit. We already have like a GLFW window and OpenGL context, so pulling in something like Nuclear would be pretty straightforward. The problem is, in order for like this script stuff that I'm thinking of to work, one, we want to like highlight segments of the text that are based off of like whatever clips are available. You could do that with something like Qt pretty easily if you inject like HTML tags to color the text. They have like rich text support, so you can like inline color tags and it would change the color. But that means that if I wanted to highlight like the current word that's being played, that means that every single frame of the video, I would be re-rendering all the text. That seems like really fucking stupid. Nuclear and Dear IamGUI didn't really seem to really fit what I wanted either. Like what I really want is I want to lay out the text one time, right? Put it somewhere on the screen, right? When the window resizes, sure, we relay out, no big deal. But I want to be able to extract the position of every single character in that text. That way, when somebody clicks, I can like know exactly what word they clicked. If I want to present something over certain words, I can do that myself, right? And Qt, I was looking at it, if it's possible, it did not seem easy. But in eGUI, you can just ask it to lay out the text for you. Your labels can take in this like galley thing, and your galley has your stuff in it. So it's like by row, you look at your row, and you have all of your glyphs, character by character, just there. You know, if you can know the position of every single character, and you can use that to reverse engineer. I shouldn't say reverse engineer. Go back to the exact word that was clicked and use that to like. Then you can go from word to timestamp by looking at the script. And so I do actually think, surprisingly, eGUI is the best fit. But the problem there is that it's written in Rust. And so we are working in Zig. So today we're going to try to get like some sort of eGUI thing up from our like Zig build system. Maybe we'll start by just trying to run any form of Rust, right? Just like a little hello world print or something would be a pretty good proof of concept. Then we can try to get like eGUI going. I want to keep as much stuff as I can on the Zig side of things, because generally I'm pretty I shouldn't say like unhappy. Just every GUI framework I use, I don't feel like it's exactly what I want. And so I like keeping the ability to swap it out easily if I decide that I like something else later better. I think is important. So the more that we can keep on the Zig side, the better, which means that if we can keep all of the like video rendering stuff on the Zig side and the like if we are rendering some custom widgets, maybe like with OpenGL, maybe that fits better on the Zig side, not really sure. But at the very least, the video player does. So it would be very cool if we could get our OpenGL context up in Rust and use it from Zig. And I think I have some ideas on how to do that, but we'll see. And then once we do that, then we can actually start adding like some sort of GUI features like a progress slider and seeking and stuff. So that's the plan. That's the plan. Long intro, but here we are. Ever think about making your own GUI framework? I don't really. It seems like a lot of like unrewarding work. Like, I think there's like a lot of edge cases there, and it would just be frustrating and boring. Is like my opinion, but I could be wrong. I'm wrong all the time. Okay, I guess our environment needs some sort of Rust in it. So let's pull that in. And then probably what's going to happen is the Zig build system can run external tools, and I think we just need to get it to run cargo build, ideally every single time we build. And then probably we want to flag that the output of the cargo build is going to be some sort of static executable that we link against. Probably. And then maybe we can say that, like, hey, you only have to compile the other stuff if that static library changed. So I think, well, where's the stuff where they have, like, running, linking to system libraries? It's not quite what I want. I want more of this stuff, generating files. So I guess we will probably in our build system add a system command to run cargo build in some specific directory where our Rust stuff lives. And then our install step will depend on, no, this is generating stuff at install time. We're going to want to link against stuff, so this isn't what we want really. Probably we want something that's a little more similar to when they produce assets for embed file. Here they have like add output file args, which is not really what we want. We're not passing in the library, like Zig will generate, or Rust will generate the output library. We kind of want like some way to just say like, hey, here's where it is. But I guess we'll figure it out. So let's just start by running a system command and see where we go from there. I think step compile has a field for setting a function. Setting a function for what? So we'll call this like run Rust build. And this will probably return the output of our static lib, which I guess means maybe we should start by actually making our Rust crate, and maybe that's a better place to start. And then once we have the library, we can try linking against it, and then we'll bake that into the build system after. So maybe we'll go in here and we'll do like cargo init, and can we initialize this as a name? We'll call this GUI. This is going to be a lib. And I think we need to change the output type. Rust produce static library. Linkage. Where do I put this in my like cargo toml? I think there's like C dilib and C something else lib. Crate type. Cargo crate type. Crate. Here we go. Crate type. Static lib. Is static lib what I want, or C static lib? I guess we'll find out. Zig build. Zig build. Oh, not Zig build, sorry, cargo build. Okay. What did this make? This made an rlib, so that's not what we want. Rlib is like a Rust static library. We want a C static library. So probably it's more like, oopsies, that's already open. So can I do like C static lib? Oopsies, wrong button. Cargo build. Unused manifest key, crate type. Okay, where are my options? Like, crate type field. Wait, oh, I saw it. It was down here. Oh. C, static lib, dilib. I swear that I've done this before. Zig. Oh, wait, hold on. This output type will create star.a. So how come I saw rlib in there? Maybe because I didn't export any seed stuff from my lib here? Like if I say, hey, Rust extern C function. No. Can I pub function, blah, 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 calling Rust code from C. Here we go. No mangle here. This is what I want. This is what I want. We'll call this GUI hello. Fuck the tests. Who needs tests? Not us. We're too good for tests. It's kind of claiming that this is wrong. Let's go back to static lib. Oh, maybe it's supposed to go here. Under lib. Lib? Let's try that. Ah, maybe it was complaining because we put it in the wrong spot. libgui.a. Perfect. And if we rm this and build again. Cool. And if we nm-c, what's it called? libgui.a and grep for GUI hello, which is what we called it. That is a symbol in here. I don't know what all of these zeros means and what T means. Man and M. Where does it tell us what each of the fields mean? T, global text symbol. So it seems like it's there. I guess maybe the it's all zeroed out still because it doesn't know where in the final executable it's going to be. So probably it'll resolve that later when we link it. Okay, so now let's see if we were to do something like can I like define a zig define C function? Extern zig extern C. Right, like I don't really want to import a header. I just want to say, hey, there is some thing that exists in the world. C import blah blah blah. It's not really what I want. Not really what I want. I feel like there must be some way to just inline be like, hey, there's a C function and he exists out there. Pub extern function, export function. No, I don't want to export it. I want extern function sounds more right. Extern function. My func. So does extern function, I guess it does seem like I don't need to write callconf C, but that seems surprising to me. I would think I do. Where is the like extern zig test variables, floats, blah, blah. One of these things must say functions, right? For if functions. And makes it use the C API. Oh, interesting. So I've been doing callconf C everywhere, but I guess export automatically doesn't, which means that extern also. Yeah, extern C. Here we go. This is what I want. Creates a reference to external symbol. Yeah, I think what we had. I think it's basically this. I think it's basically that. Let's update our git ignore to ignore source GUI Rust. Yeah, because it's annoying when not ignore Rust. I want to ignore just the Rust target stuff. Target git status. Yeah, and then when I try to search for files, it doesn't show all of the build artifacts, which is sick. Okay, so in main, let's just do something like, say, extern C function. Right, that's what they said over here. Yeah, pub extern C function. And we're going to call this a GUI hello. He takes in nothing, returns nothing. Then put a semicolon there. And so we should now just be able to say GUI hello. And then if true, return to trick the compiler into saying that everything else is still possibly available, even though this if true will always resolve. Zig build. Let's see what happens here. Probably he's going to fail and say, like, what the fuck, that function doesn't exist because we didn't link anything. Yep. So in our build, which is already open somewhere, we should just say exe link system library. Can I like add C source file, add Win32 source file? It feels like it's not a system library. And I don't know how it's gonna like behave on like recompilation, because I know that like in CMake, if you depend on some system library and then you swap out the library, it's not like fucking smart enough to rebuild itself, or at least it wasn't at some point when I was trying it. So I'm kind of concerned about the rebuild stuff. If I say link system library GUI, and then I would have to say exe add link add library path, and here it's going to be source GUI rust source GUI rust no source hello GUI rust, yeah, okay, target debug. And here we're gonna have to probably adjust this depending on debug or release, but we'll get there later. Yeah, let's try that. Let's try that. He's thinking. Okay, so now he's mad because there's a bunch of missing functions that he uses. These look like they're coming from GCC. My guess here would be, without thinking, that this is from lib standard C++. That would be my guess. And so we can just kind of do this, and if that doesn't work, we'll figure out something else. But it just looks a lot like the fact that it's coming from inside GCC, and we're already linking libc. It's like, surely it's libc++. Surely. Especially because it's like unwinding stuff, which would be used for like exception handling. So give him a sec. He's thinking. I think that what this does is it actually compiles a build, like a bundled lib standard C++ by itself. Hey, sick. Okay. So zig out, build in video editor, and then let's just zig build in front of it because I want that there all the time. Hello from Rust. Boom, baby. Let's fucking go. Okay. So let's actually set up the build as well for, so let's run Rust build. So I guess here we're going to take in the target. No, the optimization level. Built-in optimize mode. And depending on the optimize mode, we're going to link a different directory. And we're going to run a different command. So here we're going to do like, I guess this isn't technically run Rust build. It's probably setup Rust build. And then probably this is actually going to return multiple things. It's going to return the output path of the library, but it also has to return the compile step so that we can flag that our executable is reliant on this build step. So we're going to say we have some like const Rust build output is equal to some struct who has a lib path, which is this, a lazy path. And then we also are going to have the compile step, which I don't know what those are called, but we can look. I guess it's build std build step compile, or maybe just std build step. I guess we'll try std build step and see what happens. Yeah, okay. And I guess we'll start, we won't use the optimization level yet. We'll put a fix me there. I just want to get like something working. Fix me, debug, if debug, release, if release. Okay. So here we're gonna have to run some sort of executable, which we had here. And this is cargo. Then we're gonna have to add some arguments. Add args. It looks like we can do something like build. I guess that's kind of it, huh? Yeah. And then we're gonna have to put this in some directory. Can I like set the current working directory of the tool? And we're gonna set this to b path source GUI Rust. Yeah. Yeah. Seems reasonable. Oh, I missed a lot of chat messages. But you guys seem like you're just talking to each other. Make friends. Nice, noise. Okay, so we're gonna run this, and at the end, we're gonna have to say like tool run step. What is this? This is a this lives on the stack. If I return this, is that like okay? I assume it is, but it might not be. But we'll see. So step is here, and we have lib path is equal to. We'll just hard code it for now. So b path source GUI Rust target debug. Okay. And then here we're going to set up the Rust build. We're gonna say exe depends on there's some like way to set dependencies based off of steps. Maybe it's a exe step depend on Rust build step. Step? Yeah. Oh, oops, here he has to say that this returns a Rust build output, like this. And expected type build step. Okay, sure, we'll do this. This has to be a var, I guess. I don't like this. I don't like this at all. We're gonna call this run, and we're gonna return this because that's what this returns as a pointer. Then here we can call this like this, and then we don't have to do any like shenanigans with like stack stuff moving around. Because it just feels to me like the fact that we're passing this in by pointer, just feels like it's expecting stable memory location. So we're going by intuition there, and maybe this is unnecessary, but it's fine. Doesn't really matter. Okay, what happens if I zig build now? It should run cargo build. We should see that happen. Then we should see it try to include it. We did see the cargo build. And I guess we also have to say that, like, how do I add like a file dependency? Get install step depend on. So here I can say this depends on some step, which I've already done here. So it should be fine. So if I go into, maybe I go into, no, here I need to flag somewhere that there's an output file. So that it can know, the build system can say, hey, if that file changed, then this is important. So how do we do that? It's tool run, add output file arg. What does this do? He appends it to argv and then also returns a generated file here. Okay. So here, generated file step comes from self step. Rename step with output arg. Right, like somewhere there must be a way to say this is what we output. What is in this guy? It must be part of the step. That would be my intuition here. And is there like anything about... Oopsies, didn't mean to modify that. Output? Like, is there anything in here that will give us a clue? So generating files, running system tools. Here they're saying that they add output file arg, but I don't really want that. I want something that's more like, maybe I'm just like expecting the way make works as well, which might not be really true. Like with make, you need to tell it for it to correctly rebuild the dependency tree. But maybe this is enough. How could, because I know that we need the linker to rerun, and it feels like it's not. Which is my only concern here. Add run artifact. This looks like what I want. Add run artifact. Proto-gen. So this is oh no, that's not really it. Because he's still saying add output file arg. I think I've also seen like a dependency output file. That's dependencies for the tool. Add write files. So this is a build step. Add system command, out file, add output file arg. Depend on step. Yeah, okay. I guess the fact that the build is running every time is a good sign. Can we like verbose link? And then if we like touch main and then verbose link again. Yeah, okay. So we need to do something to make sure that it's like, it needs to update. So zig build, depend on static lib. I don't know, like, or zig build. It's not going to be in there. Maybe in the standard library documentation, we're going to get a better luck here. What just happened? Here it goes. This is standard library build. And if we look at step, we can depend on stuff. Nothing too crazy in here. What about step run? Where was that? Run. So file inputs, rename step with output arg. After adding an output argument, this file will default rename itself for a better display name of the build summary. Okay, I don't care about that. Has side effects. It does have side effects. Oh, dependency output file. Oh, that's not quite right either. Captured standard output, captured standard error. Rename file, file inputs, extra dependencies. So I don't really understand. Add prefix output file arg. Provides a file path as a command line argument. Asserts base knows object. For example, prefix of -o, blah, 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 blah. The output child process will see a single argument regardless of whether the prefix or base name have spaces. The returned lazy path can be used as other inputs. Oh! Oh, wait. This seems important. So the lazy path will say inside. We did see that earlier where he has like a dot generated flag. So maybe we construct our lazy path. Instead of saying like b.path, we need to construct him with generated. Okay. So how does he make a generated thing? He says the file is the output generated file, where output is an output here. So stood out step run output generated file. And this is the path. Okay, wait. This looks very promising. So here in build step run, it was output somewhere. Wait. Step run. How did we get here? This creates an output, and does it do anything with this output? No, he doesn't attach this output to the build step in any way, but the build step is attached to the generated file. So we should be able to say something like const lib path is equal to std build lazy path generated and the prefix comes from okay, let's look at this. Generated. A file that will be generated by an interface. These files are usually not available until built by build step. Generated file. The step that generates the file as well as the path. That's all we need. That's all we need. So this comes from tool run step. And the path to the generated file must be absolute relative to the build root. This value must be set in the function make of the step and not be null afterwards. So how does this get set? It gets set in the run make step. So can we like result path? Okay. No, this isn't it. Function. We're missing something here. Because what's going to happen is the build step has to... Oh, it's not generating an output folder, though. Is this the make function that's up? No, it's definitely not. I don't know how I ended up there. I searched make and then just stopped reading. But I guess our path is hard-coded. I feel like we can just write the path here. But maybe not. Let's go over to Zig and look at maybe examples in here. So let's grep for generated. Get output from translate C. Get output from run. Here we go. So these are all add prefix def var, capture std error. So these I don't really understand where the path gets filled in, right? Because this is a build generated file who is path, has a path. Oh, here, I can find references on this now. Ah, okay. So on populate generated paths. Oh, wait, okay, here we go. Where does this come from? Is this from the make step? It is. So he has populate generated paths. And if we had output placeholders, so this is not really what I want, huh? It's not really great, but I think that this kind of looks like, so he's kind of saying, hey, we have like, we generated some cache folder for this step of the build, and now we're joining that with the thing that we actually output. But we actually know where it is before we even fucking start. So we probably can actually just hard code it. I'm pretty sure. Pretty sure. I don't know if this is what you're supposed to do, but you know, we can do what we want. And we'll make this actually point to libgui.a. Then we will return the lib path here. And then just because I think that's like slightly more correct, this is supposed to be a pointer to a generated file. So I guess that means that here we need to allocate. So here we have a generated file. So here we're going to say, where do we have an allocator? B allocator? Nice. Create. And then I lost the yank, but I think it was a std build generated file. Const generated is equal to this. And then we say generated this equals to whatever we did down here. There we go. And then here we say generated equals generated. Boom. Sig build. Close cannot re-reference type because this has to say try, and then that means that this has to return an error, which means that this needs to say try, which means this needs to return an error. Does that all work? Maybe. Looks like he's okay with it. Okay, and that rebuilt? That doesn't rebuild. Okay, so now let's go into seeing if we go into the Rust code and change something in here. We'll change this for this hello smile. We will zig build, and this. And we do, in fact, see it get recompiled and rerun. Oh, that's so fucking sick. Let's go, baby. Okay, cool. Yeah, that's really sick. Really sick. Okay. Okay. Now, let us try to get some form of GUI up. I guess it would be kind of nice. It kind of sucks that our Zig project has to recompile after that change. But it's okay. We'll live. We'll live. How did that work again? I'm actually kind of confused about how this ties together. So we return a lib path to a file that we know we generated. And I guess we must... Do we use that? Lib path. We actually don't use it. So I'm surprised that that's actually doing anything. Oh, but we did say we depend on this step. I wonder if we don't have to say this actually now. And instead we say add... we can say... here that we want to use the Rust build lib path parent. So the Rust and the styles from using eGUI? Yeah, exactly. No field parent in lazy path? I thought there was. I've definitely seen a... Oh, dir name. There it is. I'm actually confused about how this got tied together, because it wasn't working this way before. But I guess maybe the build step writes down what its outputs are, and so that actually ended up doing the same thing, I guess. Like, I guess, like, it propagated through some weird dependency tree that I don't understand. Let's just do this one more time. Exclamation point. Yeah, it does rebuild it. Okay. Cool. I do feel like this is, like, a little bit clearer what's happening. So here we actually don't have to return the step anymore. We can just return the lazy path. Which is kind of neat. Return lib path like this. Because this is tied back to the build step, and then this goes away, and this says Rust lib path, or lib GUI path. Which then here turns into lib GUI path. Expected unit type found build lazy path. Oh, this can fail. Oops, forgot to write a little exclamation point there. Okay, I'm pretty sure it's working. We'll do one more test. Hello 2. Yeah, it's pretty cool. Pretty cool. Okay. So 3940. Let's pull in eFrame. So I guess we can go to eFrame in docs.rs. And we'll just copy paste our example. we're going to, instead of it being main, we are going to do this in our GUI hello, but maybe we'll call this GUI run now. This guy will be like this, and then we have to import iframe. So we can go to cargo toml, add an iframe dependency, 0.27.2. And now when we zig build, we get a little Rust dependency download. Pretty cool, pretty cool. Gotta give him a sec. He's got to think. He's got a lot of things to compile. A little 272 dependencies. Jesus. I know GUI frameworks are complicated, but that's so much stuff, man. It's so much stuff. Ugh. Rust moment. Yeah, I think I've kind of gravitated away from this idea of like yoinking in a billion dependencies. I don't like it anymore. I used to be totally fine with it. Raylib would have been better. I didn't actually look at Raylib. Maybe I should have, but I don't know. I'm already on the path, so I don't know if I'm going to go too far. But I probably should take a look to see if Raylib has the support for what I need. I need to know exactly where every character is laid out. So if Raylib can do that, that's pretty cool, and maybe it's worth taking a second look at. Okay. Driving, what was I trying to do? Changing the hello function signature. So this is GUI run now. And this is GUI run now. What changed? I'm still fine with devs personally. I think over time, I've kind of, so when I was like younger, I knew a lot less, I think. I mean, I still don't know a ton, but I knew less. And I remember thinking like, I need to pull in something like when I was working in C++, I need to pull in boost to use boost optional because I don't know how to write an optional class myself. And you look at the implementation of boost optional, you're like, holy shit, that thing is crazy. They're doing so much in there. So it must be hard. But over time, I kind of think that I've decided that the difficulty in using stuff, or like the reason that boost optional was so complex is because it needs to fit every single use case. And I think that like over time, I've kind of decided that like a library is going to try to please too many people, which is going to make it complicated. 2, it's going to try to please too many people, which means that for your use case, it's really not optimal, right? Because they're making trade-offs. Everybody has to make trade-offs everywhere, right? And 3, everything is broken, right? All code is broken. And so by eliminating complexity, you can fix stuff easier, right? So you can take up some like upfront costs to like do things yourself in order to support that later. Now, obviously, that's not true all the time, right? If you're in production and you're running an HTTP server, you need to take on that complexity. It's like complex enough that you can't do a simple thing and take it on, if that makes sense. But for a lot of things, it's like you don't need, there's like the classic like left pad node shit that happened, right? Where like you don't need to pull in some library and take on like a tree of dependencies to do something so simple, right? There is always like, I'm not saying like you don't write your own OS, right? Because you're taking on the dependency of the kernel because the kernel's doing a bunch of useful shit for you. But like that trade-off has to be worth it. And I think very often it's not. And so when I see this, I'm like, surely it doesn't need to be this bad. I mean, there's also like the classic programmer thing of like, I could write it in a week, and you're always fucking wrong. So there's definitely some of that going on. Some not invented here syndrome. But yeah, I don't know. Okay, so when we run this thing, we still say hello too, which is kind of surprising. So why is that? Oh, because this does say hello too. Maybe this is failing. So maybe we can try to unwrap this and see what's happening. So now he's got a... yeah, okay, so we are... Oh, that's kind of nice. We even get a little, like, nice core dump from an unwrap in Rust. It's kind of nice. I take in Tokyo, Serde, Rust LS quite often. Yeah, okay. So I think this is maybe a hot take. I've decided recently that I think async runtimes are a mistake. I've been really into like writing iterators recently. Like the idea of splitting out your for loops into like this like state machine allows you to do all sorts of like really cool complex things like would iterate steps of a loop and like externally inspect it with debug info, stuff like that. So I've been like kind of like into that idea. Also like abstracting complex iteration logic from usage is like super nice. And while I've been going down that path, it feels like that's all an async runtime really is they're converting your like imperative code to state machines that have like explicit yield points. And as I've like started writing more of those for sure, or sorry, as I've started writing more of those, it feels like they're not that hard to write. And if they're not that hard to write, is it really that hard to use epoll to connect your sockets to your thing and like then write your state machine yourself? I get like the idea of like not wanting to use epoll because it's like system agnostic, but like maybe like an event loop with callbacks is better than trying to auto convert your async code, because I feel like you run into so much shit that's just difficult because of that. And if you like didn't hide the complexity behind these like async runtime keywords, then maybe it would make more sense as you're trying to debug. Maybe, I don't know. I've been kind of feeling more that way recently. I think that if I go back to Rust, I don't think I'll be writing much async. Probably. I could be wrong though. Maybe I'll change my mind. I change my mind a lot. Okay, so he is getting mad because no Wayland lib. Oh, right. So eGUI like dynamically loads a bunch of shit that's just probably not in my Nix environment. So we can just go into a previous project where we've used eGUI, like over here, and just kind of yoink all of this shit. And figure it out in a second. This will probably fix it. Okay. So what's in here? This stuff doesn't matter. Bind gen hook. I don't think we're doing any bind gen right now, but we might later. So it's fine. We'll take that out. Curses, package config, OpenSSL. All this doesn't matter. I think it's mostly this stuff that's important. We say like, hey, here's a bunch of shit. Please use it. I had a ton of async headaches in my last professional project, but I learned a lot after writing a couple times before shipping. Yeah, I mean, I don't think it's like necessarily that bad. I mean, I like the idea of async a lot. It's just I'm not convinced anymore that it's like the best way to solve that problem. Look at that. This is kind of sick, isn't it? Look at that. So we have a window open, and let's try to get like their like hello triangle example running. And then see if we can like, well, how do we want to do this? Yeah, let's start with the eFrame hello triangle. I guess it's gonna be in the eFrame examples. Can we get a Zig project with IOU ring? I did actually, when I was working on the operating system stuff, the last thing that I wanted to do, I did want to do like an IOU ring experimentation, because I don't really know how it works, but it seems very cool and better. Like the idea that we read and write to the hard drive in a blocking manner by default is so batshit crazy to me. Like, so obviously fucking wrong. Disks are so fucking slow. But like, it's the way we've done it for forever, and it like really bothers me. So IOU ring is like pretty cool. I like the idea. I want to check it out at some point. Examples. Custom 3D glow. This is the one. This is the one. Okay. So I guess we can just copy paste this whole thing into our lib. Oh, you're saying thanks like I said yes? I'm not guaranteeing that I'm going to do it. I'm just saying that I like the idea of doing it. What is going on here? Oh, right. Zig builds. I took out the run step because I don't like it. Nvlogger, fuck off. Okay, he builds. Let's see if we get, GUI run is not defined, right? Because we called this main here now. And so we just need to change this back to, extern C GUI run like this. Function? How does the language work again? Pub extern function GUI run. And then here, unwrap. Okay, let's try that. Let's try that. undefined symbol GUI run. Am I high? Oh, no mangle. No mangle. I forgot that he mangles. All right, there we go. Okay, so we have our OpenGL triangle. Oh, fuck. I forgot to write down the time, which means that later when I'm trying to generate timestamps for my YouTube video, it's going to be a pain in the ass, so we'll just put a little... Okay, so now what's kind of interesting here is the OpenGL context is now managed by Rust and eGUI. And we want to like maybe use these OpenGL functions from the Zig side. Probably the easiest thing to do would actually be to just copy our shaders over to the Rust side and like run our frame translation from YUV to RGB on the Rust side. But again, just to reiterate, I really want to preserve the ability to swap the GUI out. So the less stuff we can do on the GUI side, the better. But I do think that every GUI framework is going to initialize its own OpenGL context, right? Because if you're asking the GUI to spawn a window, you ask Qt spawn a window, you ask eGUI spawn a window, you ask anyone spawn a window, they're going to have to interact with the OS in some way to be like, hey, can I get a window? And then if they're trying to draw anything, they're going to have to get their own OpenGL context. So trying to manage our own OpenGL context alongside it doesn't really make sense. Maybe you could say, hey, eGUI, could you give us the loader address? And we could like generate our own OpenGL bindings on our side. But I was trying skimming the docs earlier and I couldn't find any way to get that out, right? If we look at the like frame, I think is what they give us. They give us this guy. And from here, you can definitely extract like an OpenGL context. But there's no like window handle thing. And I don't think that this OpenGL context lets you like extract a loader. Like you can construct this OpenGL context with a loader. But when I was looking at the source code, it looks like eFrame kind of internally passes in their internal window representation. So unfortunately, I don't think it's that simple. And also, you know, you could argue that we don't have the guarantee later that this is going to work. So I think what I'm thinking is maybe the GUI will give us some callbacks that we can call that do the OpenGL operations that we want to do. Because also we can't just like call like free functions, because if you look at the Glow implementation here, the way that their loader actually works is their context stores the function pointers, I think. Maybe it's easier to clone this. Oopsies, cd ... And if we go to Glow, Glow Rust GitHub, probably this guy, GL on whatever, I think this is what it's called. Yeah, that's gotta be it. Git clone. So I think it's in here. This is where they do all of their function bindings. Yeah, see, all of these guys are member variables of this struct. So there isn't like when you use like glad to do your OpenGL bindings, all of your function pointers end up getting like bound to like the global namespace. That's not how this works, and they just kind of like bind them all by structure, which actually makes more sense, right? Putting them in global is like not necessarily reasonable, but it does just mean that we don't have the ability to say like, hey, I'm just going to call this function. I'll just tell the linker, hey, they have the GL bindings, and then like call it. We can't do that. So I think it makes most sense to maybe, how do we want to do this? What makes sense? I'm not really sure yet. Probably you're going to have like some GUI object returned by Rust. So we're going to have like, some sort of GUI in Rustland, and he's going to maybe have some functions associated with him, like an extern no mangle extern C function, extern blah 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 function that's like get GL callbacks. Let's think if this is how we want to do it. And he's going to return some sort of like struct GL callbacks, right? Then in this world, from Zig, we'll do, maybe I'll put a little, make it look like markdown title. On Zig side, we would say like, GUI is equal to make GUI, something like that. We'll ignore the names for now. which means that this guy's gonna have like extern function make GUI, whatever. Then we're gonna say like GUI or get GL callbacks with the GUI. So this was gonna have to say like GUI, whatever, right? Then we have like our callbacks. Then we would have our like our renderer is going to be some sort of like Zig renderer given the callbacks. This is going to be run on the GUI thread. So this guy's going to have some sort of like on GUI thread. We're going to have some sort of like renderer render. And then on the main thread, we're going to do something like renderer set frame data. And then maybe we would do something like renderer handle instead, so that it's clear where each guy lives. Which means that here we would have to do something like set GUI GUI set renderer or something. Maybe renderer GUI set some form of callback. GUI set renderer. We pass in the renderer like this. Because on the Rust side, the way that this is the eGUI stuff works is they say, hey, at some point in your main loop, could you run this function for us? And this function actually eGUI will set up the OpenGL context so that it's going to like the correct frame buffer or whatever, and then he'll call this function, and we just like call GL stuff directly in this paint function. So we're gonna like replace this with like call Zig renderer in some way. So we have kind of like a couple options here. One is that we could export in Zigland a C function that's just like render video. And this guy could just call this, maybe with some user data. I think that probably makes sense. And then the other thing we could do is we could pass in a function pointer to the GUI. But I think it makes sense for the GUI to live within the world of our within the world of our project. I think that's fine. So this seems reasonable to me. We'll like implement some function on the Zig side. We'll tell Rust that that function exists. Rust will call it, but we have to feed Rust the renderer that we are using because we don't want to just store that shit in the global space because, well, for no real good reason, just because it feels bad. We hate globals as programmers. We hate them. Everybody hates them. So let's maybe start with, we'll kind of say that this section was like, design Zig Rust API, we'll call it. Here we'll say that we are testing Zig function called from Rust. Then at some point, we will render frame from Zig from Rust from Zig. Perfect. Okay. So for now, though, let's just say that we have some sort of pub extern function, and we'll call it Zig hello. And all he's going to do right now is going to say sudo debug print and say hello from Zig. Extern functions have no body, so it's not extern. What was it called? Export. And so now, from here, we should be able to call Zig hello from this side. And I guess on this side, we also have to say that there's like some function that we can call. So extern C. And he's going to say like Zig hello is a function that takes in nothing and returns nothing. This isn't how void works, so I just leave it unset in this language? I think so. How do I learn programming? This seems so hard. I mean, I think that we're getting into like wacky shit territory. I don't think the majority of people that I've worked with would have had experience doing this stuff, right? And I like it's even like build system knowledge around programmers seems to be you don't need it that much. I think it's like surprisingly unknown because when you go to work at some company, right, they usually have a project already, and so you're just like kind of like modifying things within the confines of their existing build system. So we're getting into like stuff that like people don't usually do this stuff, and so you don't have to feel like, oh, this is hard. I think what's important is the ability to kind of figure stuff out, and so you're kind of seeing like this like unfair representation where I have like a lot of years of experience in digging into this type of shit, so I have like a pretty good intuition. Well, I don't know. Maybe I'm overstating it, but I feel like I have a decent intuition on what to do next here. But the first time I did this, I was fucking lost. And what I did was just like, I know that I want this thing. How the fuck do I do it? And you just like slam your head into the wall over and over again and punch Google a few times. And eventually, with enough persistence, you get there. But yeah, I think the general answer to how do I learn is just do. Just join. Can you explain how these two languages can work together? Both work with C, and both can export C functions. So we build this like glue that is basically like the C. This is a what's that? I was trying to draw two arrows, but then I accidentally made the little smiling guy face. What's that? Did I do that? Emote. Emote. Finger. Thumbs. Pointing together. Yeah, this guy. Yeah, arrow, W, arrow, perfect. Anyways, so since both can speak to C, because every language really does need to speak to C, right? Because like your system is written in C, talking to the operating system is through C, and so your languages have some bindings to that. And if they also export C bindings, you can just pretend from both languages that the other language is C, and so that's what we're doing here. That is what we're doing here. Okay, so we have this zig hello function who we say is here. The linker should find it, and he should say like, I think there's nothing to do here. I think it'll just work. Zig build and run this. And so, yeah, we see hello from Zig on every pane, which is really good. Really good. So I guess now what we probably want to do is we want to start, we want to do something like get Zig struct into Rustland so that we can do this like render thing where we can like set the renderer on Rust side and feed him in this thing in, and then we'll change our Zig hello thing to take in some context, who is going to be some any opaque pointer, right? I guess technically we could just say it's what we expect. That's probably fine. I wonder if you can export a function from within a struct namespace like that, like this. That'd be kind of wild. If you could do something like a const struct is equal to a Zig renderer, we'll call it. And like, can you do like this? Oopsies. This is const Zig renderer is equal to struct. Like, is this legal? And then can we take in like our Zig or self as a Zig renderer? Like, will this just work okay? Unused function parameter. Undefined symbol Zig hello. So it looks like this probably gets mangled in some way. Okay, so we'll do it this way. We'll put it outside. Syscall API really isn't that complex or C-based, but pretty much every library that would want to interface with this human has C or C interface. Yeah, that's true. But I think that it is rare for people to interact with the syscall interface directly. I will say that, right? The chance that people are using libc is very high. You may need to export struct. Yeah, we could try that. I don't really know how, so I'm just gonna give up. We're just gonna do it here. I'll come back to try this off stream, maybe. Maybe I won't. But maybe I will. Who knows? So here we can put in some like state. So here we'll just make it like an I32. We'll say self defer self state plus equals 1. And then we'll try to print the number. Yeah, that seems reasonable. And then we are going to need to feed the GUI. So lib here, we're going to say that we are going to export some function that is like GUI. I guess here we need to make a GUI structure. So here, this is going to return what I guess is a pointer to GUI. Do I have to write mute here in this language? I can't remember. Fuck. Oh my god. I'm so stale. It's not like this. Rust pointers. How do I... Star mute. Yeah, oh. So yeah, like this. Oh, because it's an arrow. Dude, I'm so fucking lost. Okay, we'll change my app to be GUI here. Everywhere where it said my app, we'll name this GUI, and then we'll make it so that our GUI run only does the second half. Oh, we can't do, yeah, we can't do that. So we can say, here, that we return this thing, but we leak it. How do you leak a box again? Box. Because you keep switching languages. Yeah, it's pretty hard. My poor little brain. We'll get there, though. Not here. Box in, Rust. There's a way to, like, leak it. Leak it. Yeah, it's just leak. Oh, because you're supposed to call, box leak this way. They like that better. Consider removing the borrow. Cannot find CC in this scope. Oh, that's annoying. That's annoying. So maybe what we'll do instead is we'll call this GUI state. And for now, he's going to have nothing in him. Oh, no, he's going to have the renderer. Renderer. Who is going to be some sort of, like, void pointer, I guess. We don't really care what he is. Yeah. 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 And so here we're going to return some GUI state. We're going to say, const let state is equal to GUI state. Right? Is this how you do this in this language? Renderer is stood pointer null mute. Oh god, everything hurts. My poor little stupid brain. And then we construct a new thing out of this state. So he starts on the stack, we put it on the heap. This guy needs to be marked pub because he thinks he's not allowed out there. Okay, and then we're gonna have some sort of function that's like a GUI set renderer. You can share memory between Rust and Zig, or you're returning pointer, so I guess yes. Yeah, I mean, it's all just on the heap, right? So Zig, they're gonna be using different allocators, but both of their allocators are going to, at some point, slap the OS and say, yo, could I get some memory, please? And that comes from, like, the kernel through just, like, some syscall API. I think that what's common is for people to, like, map pages of memory into their process. And so both of these processes are going to be mapping different pages in, but they're still within the process, even though they both, like, they were asked for by different people, or I should say, like, different structs within the program. They still have, like, memory addresses that are, like, the same. Now, what we're doing right now is we're not actually exposing the internals of these structures to the other language, but you could do that as well. Instead, we're kind of hiding behind what they call, like, opaque pointers in C. So we define, like, the implementation of this thing, and we just never return, like, the actual thing. We only return pointers to it, and so the other guy only needs to know, oh, okay, I have some pointer, but, like, I'm not going to worry about it. It's just, like, it's just a pointer, and I'll pass it back when I need to. So this guy's going to take in a state, which is a mutable GUI state. And then he's just going to say, he's also going to take in a renderer, who, from his perspective, can just be a void pointer. We're gonna have to get kind of crazy here later. It will make more sense to generate these bindings based off of C header that both languages include. That's gonna be way easier to deal with, but I want to maybe get there a little bit later. So we can do something like state renderer. How do I dereference a pointer in this language? Like this? Then this all has to be unsafe, of course. This public function might dereference a raw pointer, but is not marked unsafe. But it's in an unsafe block. Isn't that fine? Yeah, it seems like it's fine. It's just maybe just like a clippy lint or something. So in our main, we now have GUI new, who returns a GUI state, GUI run, who has to take in a GUI state, which means that we also probably need a GUI free to free the GUI state. Yeah, and this is, when we free this guy, we're just going to say box from raw based off the state. And by doing this, he will immediately go out of scope and call his own destructor, which is fine. And that's how we will free this guy. Okay. So now over on this side, we now have a GUI new who is going to return a mute GUI state, which means that we have to have extern const GUI state is equal to, I don't know how this does like opaque structs. Okay, opaque struct zig. Like how do we? This is C, C++. Oh, here we go. If you don't blah 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 blah. Okay, here's what we'll do. I don't want to think about it. He's going to return us an any opaque. GUI run is going to take in a any, or he's going to take in a C void, which I guess is what we should do here, actually. Is this how you do it? No, they want any opaque. I'm not sure. This is a little sketchy, but we'll do it this way. We'll do it this way. We will do it this way. And then we have GUI set renderer. And from our perspective, it's fine. Yeah, it's fine. Okay. So this guy now, when we run this guy, we're going to have to pass in the state to our GUI, which means that this guy's going to have to take in a state. And then he is going to store it here. And then all of that was so that when we... Oh, this guy also needs the GUI state. Which means that down here, we need to take in state. State is a star mute GUI state. Are we doing GUI in Rust? Yeah, the GUI is coming from Rust, and the everything useful is coming from Zig. State. So here we should be able to do, we pass in our state renderer, like this. Oh, it's already unsafe, sick. And now we need to say that Zig hello takes in a void pointer. So we'll say renderer is this. All right, maybe. Maybe maybe this will work. I'm honestly not sure. There's a lot that I could have done wrong here. Oh, wait, we're not done yet. We need to, from here, we need to say const GUI is equal to GUI new. Defer GUI free GUI. And then we have GUI run with the GUI. But before that, we can say GUI set renderer. GUI renderer. Which means that here we have to say const renderer is equal to, nope, not const. Var renderer is a zig renderer. No allocators? I don't think we need it yet. I don't think we need it yet. Okay. So if we get all of this right, at the end of all this, we should be able to say std debug print. The state is going to be renderer state. And hopefully this lines up with what we see printed. No, allocators is a free. That's what I thought there'd be allocators. Oh, but the it's allocated on the Rust side. So Rust is just going to use its C allocator in the box. We could pass in a Zig allocator probably, but that's just like way more work, and I don't think it really gains us like literally anything. Mute GUI state cannot be sent between threads safely. Fuck off! Oh, I'm so used to being able to do what I want. Oh, okay. Impl unsafe impl send for GUI state. Unsafe impl sync for GUI state. Oh, the freedom! It felt so good, and now we're back to, you know, he's right? Like it is. He should be telling us what to do, but state is state. Replace it with state. Okay. Expected this, found that, so 20. Oh, oops. I thought I fixed that. And this should be impulse sync. I must have hit undo a few times by mistake. Oh, but it's fucking poo. Fuck. So, can I? Oh, what a pain in my ass. So the problem is that, like, can I implement this for this? Is that legal? Consider implementing a wrapper type? Oh, why? Fine, I know, I could, god damn it. God fucking, fuck. That's so... okay. Fine, I guess struct GUI state pointer is a mute GUI state. Ah. Fine. Like, you know, we'll do it your way. We'll do it your way. So, where's it getting mad? It's getting mad at around 119. So here, when we move this guy between threads, this needs to take in our rotating triangle. So this guy probably needs a GUI state pointer now that is marked as being allowed to be moved. This guy takes in a GUI state pointer. And when we construct our rotating triangle, we need to construct this as a GUI state pointer. So const state pointer is a GUI state pointer that takes in state, and then this becomes state pointer. Really? Provide a type for the constant? Oh, because this is let in this language? My bad. My bad. And then self.state cannot be dereferenced, but we can dereference the inside thing. Borrowed value does not live long enough, so 50, this needs to say move me please. Okay, close, closer now. Read declaration of constant GUI, so main 234, right, because we're still in the rest of our world. So we'll call this a Rust GUI instead of GUI so that we don't have to deal with name collisions. Local variable is never mutated, so this is 215. Because we have to set it to the pointer, not the actual thing. Okay, and let's try running it. So, okay, so the counter is increasing, which is really good. We can see that that's going up to 75. And if we close this, it does have a state associated with it at the end. So this is printed from Zig. This is also printed from Zig, but this is like going back through Rust, and this is in Zig directly, and it's getting like the same numbers. That's a really good sign. Really good sign. So that means that like this pointer is being passed to the GUI is running him correctly, and then at the end we have a value in our stack allocated thing on the Zig side that matches up with all the changes that Rust did, which indicates that we aren't accidentally sending Rust invalid memory in any way. Everything is kind of like modifying the memory that we expect it to. Which means that now we should be able to start getting crazy. Yeah, I wonder what happens now if we just construct our GUI here. We can construct our GUI, set the frame data, and maybe everything just works, to be honest. Oh no, because our GUI needs to he needs to be fed callbacks from the Rust side. Okay. So that means that we need to kind of extract the glow bindings, which kind of breaks this idea of our like GUI new only returning like GUI state here, because we need this to run a little bit. Is this like a, can we ask him for like a little bit more of like a staged initialize? If we look up iframe, do we need to go through that run native thing, or is there a way for us to kind of get inside him and get a little crazy? Right? Like, what's he doing inside? Zig plus Rust, are you using both in your project or what? Yeah, we're getting crazy. So he doesn't do a lot in here. He extracts the renderer and then just runs it with glow. And is this a public function? No. No, it is not. So what I'm trying to figure out is if we can extract the OpenGL context from this thing before we start the GUI. Because if not, then we're going to have to stick a callback on the Zig side, which is fine. It's nothing in the world. It's just like a little annoying. Just a little annoying. But it's like reasonable. You know? It is reasonable. What's the difference between run native and run simple native? Oh, interesting. Run simple native. I've never seen this before. That's really nice. So you don't have to make this struct and create like the interface on them and stuff. You can just say like, hey, here's the thing. So my guess here is that the glow context actually doesn't exist until we run this. Probably if we were to like go into iframe and look. Iframe or just eGUI. There we go. Creates iframe. If we were to look at native, what was it called? Glow. Run glow. Here we go. Native run glow. He probably constructs the glow context here. Glow winit app. Running, where does like the context come from? Glow when it running. Yeah. Okay, here it is. Yeah. Okay. So I think this isn't trivial. So probably what makes more sense here is for us to, sorry, brain's melting. It probably makes more sense for us to provide a callback on the Zig side where it can inject us with the function callbacks. Are you using Tmux? Yeah. Tmux, Alacrity, KDE, NixOS is kind of like the stack of what we're working with here. But, you know, and Vim, I guess. But I will say, I used VS Code for a long time, and it was totally fine. Just running like Terminator and VS Code, I don't think is any I don't think that like it makes you better to use this stuff. You know? It like I do think it's faster, but is it worth investing the time? I think so, but I would never tell anybody else that they should take on basically anything in that whole stack. I would never recommend to anybody unless they really wanted it already. You know? It's like one of those things where you wouldn't want somebody to be mad at you for saying you should try this thing, and they're like, "What the fuck? You just ruined my life." It's fun to learn new things. That's true. I think so. So, you know, if you see your coworkers using VS Code, it's not like they're doing anything wrong. VS Code's great. Vim is cool to learn the bindings, but you don't have to go into the Vim itself. I will say that the macro system is quite good. And I've never felt that, like, whenever I use Vim binding somewhere else, it always feels like a little bit off. You know? So that's why I'm still here. Otherwise, I would probably be somewhere else. But yeah, it's hard. It's hard to fully switch off once you start getting into the nitty gritty. Okay, so what's the next step? The next step is feed opengl callbacks into Zig from Rust. That's kind of like what we're at now. So probably what we're gonna do. How does this work right now? How does this work right now? So we can make it so that the renderer doesn't depend on the GUI at all. In fact, the renderer doesn't depend on the GUI right now, which kind of makes it so that we can pass in the renderer pointer here when we construct our GUI, and then he will tell the renderer what the callbacks are when he starts running. Down here. I think that makes sense. So here we'll take in the renderer as a mute C void. We can kind of like get rid of this GUI state thing, I think, because now it's all going to live directly inside. We still do need this like GUI state pointer, but we'll call this a renderer pointer. And this is going to point to a mute C void now, which is our renderer representation on the Rust side. This GUI new, I guess, doesn't actually have to exist. And this doesn't have to exist. It's actually just here, where we're going to run with the renderer. Then from here, we're going to turn this thing into a renderer is a, oh, there's shadowing. Shadowing's legal here. I love shadowing. I love it. Hell yeah. And then we can pass this in like this. Oh, it's good to be back sometimes. Shadowing is so good. Yeah, I mean, I do get the arguments against it. It is kind of like asking for problems in some ways. But when you're doing like transformations on an object that changes its type, it seems like equally valid to me to change the type of something and to change the content of it. So like I get like the argument where it's like very error prone because you might like accidentally lose something and you think you're working with one thing but you're working with something else. But the idea of being like, I'm going to transform this thing from type A to type B to type C in this like sequence of steps, it like totally makes sense to me in that scenario, like this, right? Where we actually like, don't want to use this ever again after. Yeah. So now our GUI is constructed with a renderer pointer. Shadowing's bad when you don't have a REPL. I don't understand what a REPL has to do with it, to be honest. This guy takes in our renderer now. And I guess he doesn't store the state here. It's only in the rotating triangle side that he's using it right now, which is fine. Which means that this guy takes in a renderer pointer. This is a renderer pointer. And this is a renderer here. Which means that this has to be called renderer here. What a pain. What a pain. Okay, I think it's like this. I think all of that should still just continue working the way it was working before. GUI new, GUI free, GUI set renderer are gone because now we construct the renderer like this and then we just run it with our renderer. Okay, and it looks like that's still performing how we expect. So, cool, cool, cool. Hello, Chief. How are you? What are we building? We are building our video editor. We are trying to get a GUI up and running. We're working in Zig, and there are no like really flushed out Zig GUI frameworks. The GUI frameworks that I would naturally use, like Nuclear, IMGUI, Qt, none of them seem to really provide the features that I need for our video editor, because our video editor, we want to basically attach the timeline to a script and be able to scrub the script like you would scrub the timeline. Which means that you need to like render some things on the script based off of their exact the pixel positions of each character. You also want to be able to select things, so you want to be able to go from character to position on screen and from position on screen back to character. And so eGUI was the only GUI framework that I've like used before where I think that that's possible because you can like pre-lay out text. And so because of that, we are in this world where we're trying to build Rust from Zig, call into Rust from Zig to get our GUI running, and keep as much in the Zig side as we can because this system's silly. And like, surely there's a better option. I just haven't found it yet. So being able to swap with the GUI in the future will make things easier. Apologies for that aside for everybody who already was aware of what we're doing, but I think it's good to reiterate every once in a while because we are a stream where people just come in and they leave, and it's hard to jump into the middle of something. So I'm okay reiterating every once in a while. Okay. So here we have passed the renderer over, and so now we need to expose some function that's like set a renderer. What do we want to call this? Frame renderer. Frame renderer. How do we? Okay, so this stuff's gone. This is gone. This is gone. This is gone. And I guess we want to do export function, frame renderer, set callbacks. And here is where I feel like it makes sense to start pulling in, like, actually make a C header for this stuff, because this is going to be like some struct that has a bunch of shit inside it, and I don't want to deal with that right now. So let's say it's easier. I was gonna say it's easier to run your own immediate UI, but rendering text is hard. Yeah, I actually was like looking at it. I wasn't putting it out of the question to try to lay out the text myself because it's not that bad. It's just not bad enough that I want. It's like bad enough that I don't want to do it. Once you decide what project you want to work on, how do you do planning research about it? Would be helpful to learn. C being the lingua franca of programming. Yeah, I think it's mostly I have a bunch of state in my head from things I've looked at before that I've built up from years of just being like, I want to do something, and then you do it. And in terms of like, what do you do? Like, I think it's per project, but you just Google, how do I do this? And you start piecing together the pieces, right? So here, for this project, it would have been like, how do I, like, what I was looking up here was like, is it possible for me to generate subtitles? And I saw like, there is this like Open Whisper AI thing that lets you, OpenAI Whisper, sorry, that lets you convert, like create subtitles out of audio. I looked at their Python bindings and I tried it, and I saw that there were timestamps associated with the things that you're putting in. Even if there weren't, you feed it in PCM audio and you get timestamps out. So I was like looking at the source code for that, trying to figure out how it worked. Then I was like, how do I like re-encode video? And you look at like FFmpeg and you try to figure out how to use like the FFmpeg libraries, and you kind of like can like piece together like, okay, so I know that part. You kind of just start with like highest risk things, and you just de-risk them one by one until you get to the end. Is kind of how I do it. But okay. Not gonna lie, this project would be done if you used Electron. I don't know. So okay, I was legitimately considering trying to use the web as like a UI for this, because I like the idea of not pulling in a GUI dependency, but instead just using the browser that everyone has installed already. I really like that idea. So I was like researching like mpeg dash, I think it's called, which is this like protocol that you can use to like send frames from one area to the other. Because like the problem is like if I'm working with like a 2 hour, frames from like your server to the client, like real time stream them. And because the problem is that you can't upload a 2 hour video to your website. Like that's insane. That's just way too much data, right? And so you would actually need to have something like on the back and front end. If I were to use Electron, I don't know how to get like a frame of video in there. I don't know how to render a video frame in Electron. So like I actually think this is faster for me, because like I understand how to get an OpenGL frame and I understand how to draw stuff in an OpenGL frame. And so like I don't actually think that Electron makes anything easier there. Because like I just don't know how you get like what you need to get there. It feels like a complex path, video, but you need to be able to like custom feed in your frames at some point, right? And so like if you use video tags in HTML, you need to feed that video element in some way, which requires some sort of JavaScript glue to like grab frames from somewhere, right? And it's just like I assume that the backend front end stuff is like it would be almost as hard in Electron, I would imagine, as from how do I say this? As on a browser. But I'm not really sure. I don't know if in Electron you can just get a buffer to like a pointer to a buffer in some memory that you've like written in some C glue for. Maybe that's fine. I've never actually worked with like those frameworks before, so I don't actually know. But that would make it not so bad. I could imagine something similar to Python, where in Python you can add C extensions where you can just look at C memory, and then it wouldn't be so bad. Yeah, because like you're saying, then you could use a canvas and just display on the canvas, and that would be fine. But I'm just saying all this to be like, I actually don't think it's trivial. And I don't know if it would be easier, to be honest. I think I would have to learn just as much. At that point, just use WASM. But then you're still stuck with the problem of needing to get the video into the browser. And it's like 6 gigs, right? Like, okay. What was next? We're trying to split out C headers. So this is kind of like we're at 013755, and let's do split out C header for interface. Okay. So maybe we'll put it kind of like in source GUI GUI.h. And for now, we will just do something like say like Rust side and put another comment for Zig side. We need to do include guards in this language. So if not defined GUI h, define GUI h, and end if. Yeah, end if, like this. I'm so fucking rusty, dude. Holy, it's bad. Okay, so here we're gonna say we have this function zig hello, which is a function that returns void and takes in a renderer, which is a struct zig renderer pointer. Then here we need to say that we have some sort of struct zig renderer. Would it be a problem to use a pragma here? I actually don't know. I kind of, in my head, pragma once was C++, but I guess that's not true. Okay, in lib.rs, we are going to have just this thing. So this is a void function GUI run that takes in a renderer, which is just the struct zig renderer star renderer. And that means this goes here. So maybe we'll call this like common types, Rust functions, Zig functions. There's nothing wrong with include cards though. There actually is. I think it's easy to copy paste headers and then forget to change the include cards. But there's something wrong with pragma once where if you have symlinks to the same header, I think that it gets included twice. So I think both pragma once and include cards have their issues, if I remember correctly. I'm new to the stream. Do you mind if I ask what you work on for your day job? I actually got. I think calling it burnout is a little strong, but I was pretty tired at work, and I just quit one day because I was just like, I'm so tired of being tired. So we're on a year off for burnout recovery, whatever you want to call it. I don't know if burnout's a little strong, probably. But we're on a year off right now where we're doing this for fun because I like coding. I just was tired of all the bullshit that came with it when you work a normal job where you have responsibilities and like people want your code to work and like they want you to do your job, right? Like, you know. So we're having fun coding for now. We'll see what happens. I gave myself a year, and you know, there's a chance I extend it if I feel like this is going well enough that maybe I can make money. Right, but for now I'm willing to just eat the loss for some time and have fun. So that's what we're doing right now. But I did used to work with C++ a lot with like camera firmware, a little bit of C. We ran like Linux cameras, so a little bit of like kernel driver development, user space application stuff for like sending security camera. Like you get this box and it's got some hardware in it. You're like, make it boot, make it do stuff, please. And then. Yeah, so that was fun. I worked on like the camera firmware. I worked on the software that like played back and recorded stuff. Then I worked at this like company that did neural networks for like picking stuff up. So we would like position two cameras up in the air, and we would like look at this box of shit, and you'd be like, "Hey, robot, could you pick that shit up?" And so you have to like have some sort of fancy heuristic of what is that thing that you're trying to pick up, how is it oriented, if you were to like find it in 3D space, like how is it in your hand, all that type of shit. So that was a lot of like Python neural network stuff and little C++ application development. So yeah, I don't know, normal shit, I guess. I'm sorry, health and mental, physical is so important, have a nice recovery. Yeah, I don't think that it's like, that's why I'm like worried to call it burnout, because I don't feel like I was doing that bad. I was just like tired, right? Like, and my tolerance for shit is probably quite low, right? I just like, you know, if I was like short on money, if I lived a little bit more extravagantly and I hadn't been saving so aggressively, it's not like I had to quit, right? It was just like I like went home and I looked at my bank account and I was like, I could take a year. Like, fuck it, I don't need money right now. But that's also because I have no desire to do anything with the money. Like, I'm never fucking buying a house, dude. There's no fucking way. So, like, what's it for? If not this, being able to take some time and enjoy yourself, you know? Okay. So, is this really our whole interface right now? It is for now. Why no house? Bro, do you think I'm ever making that much money in my life? Fuck no. They're so expensive. But I also live in Vancouver, which is, I think I saw somewhere that it's like third most expensive city for housing in the world or something. So if I was willing to move, maybe I'd be more into it. Do you do stuff art? Do you just work and code? What else is there? Coding is real life. It's all there is. Hope you don't get the classic, can you explain this gap in your resume? Well, that's exactly why I'm doing this, actually. Because, like, now I have a year of stuff where I can show them and be like, look at all this shit we did. Two, if I, like, when I go back, dude, do you know how fucking easy it's gonna be to, like, nail an interview now? With, like, the amount of practice that this is giving me on, like, talking and coding at the same time? Dude, I'm gonna fucking kill it in an interview room. It's gonna be sick. So, yeah, it's like good. That's kind of why like the stream is fun, but it also gives it's a good backup plan and like stretch goal, right? It's like if it works, then I just don't have to go back, and if it doesn't work, then like my resume and my interview skills are just like off the fucking charts. So it's like fine, both are great. Okay, Okay, so we need to generate Rust bindings for C code. So I think it's either bindgen or C bindgen. I don't remember which. One is one way and one's the other. Bindgen, for example, given cool.h generates this Rust code. So I think that we want to use bindgen to generate stuff. And then I'm hoping that we should check this now. If I say in Rustland that there is this function that we're implementing, is everything okay? This is in lib.rs. We have this GUI run. If I just take this and I shove this like this, is that legal? Or do I have to like stub out the Rust functions? Previous definition here. GUI run must only be defined once in the value namespace of this module. Okay, so how do I... Is there really no... Can I not generate bindings? Rust... What's like C bindgen then? Rust C bindgen. Is it the other way? C bindings from Rust code. Because it would be nice if I could like define the functions in the C header and then just make sure that like the type definitions match on the Rust side. That was what I was kind of hoping I could do. But it does kind of seem like that's not like based off of this. It doesn't really look like it's going to allow that. Wait, why are we using arc and mutex? Do we introduce threads? I just copy pasted the eGUI example and I haven't really thought about it. We haven't really done like the eGUI, like GUI stuff right now is like almost non-existent. All we've done is tried interacting with Zig and we haven't like really customized it at all. Black. Okay, so there's like a couple options here. One is we could generate rust.h from C bindgen. And then in Zigland include rust GUI.h, I guess we call it. And then on this side, from Rust, include GUI.h. So in GUI.h, we'll define this like Zig renderer and everything except for the Rust functions. It'll go like all the way down to here. And I think that's still fine because then we can still define our like struct GUI, what do we want to call it? GL callbacks. Then here we would define our like set GUI callbacks. Or set GL callbacks, right? And this would take in a struct GL callbacks star callbacks. And I think that everything else there still just kind of works okay. So we call this from the Rust side, from this function. Yeah, I think that all kind of works out. Kind of gross. I would have preferred to be able to just do one header, but two's not the end of the world. Which is kind of odd because now we're going to have to inform the Zig build system that Rust's build system is generating code based off of the Rust code. Oh, gross! Oh, I hate it. Oh God. Thanks, chatters, for covering the what are we coding question. I like to reiterate, but somebody just asked very recently, so I don't want to go too far into it again. But the short answer is video editor with subtitle generation. So we want to be able to use the subtitles in order to seek within the editor so that we can like quickly clip stuff based off of text instead of based off of sound, essentially. Okay. So I guess we have to figure out how to use C bindgen. Read the full user docs. Blech. User docs, gross. So in our build script on the Rust side, we basically make a bindings header that comes from some C API. So I guess what probably happens is he probably walks our whole crate for no mangle pub functions. He probably figures that out for himself. And so all I have to do is just generate this in the build script. Let's try that. So if we go to build sorry. Source GUI Rust build rs. Function build, or function main in this language? Function main. Okay, so we'll just kind of do what he says to do here. Just copy paste this shit. Copy paste this shit. Still more sane than C++ project build systems? I don't know, man. I guess CMake is pretty fucked. The idea of your build system generator, and that's how we ended up, is insane. I do like the idea of like configuring stuff in the language you're writing in. I think mixing these languages is going to cause me some pain, but you know, it's fine. We're having fun. Oops, source, GUI, Rust, cargo, toml. And in here we have dev dependencies, which I can never spell, dependencies. C bindgen equal to, I probably could just copy paste this, huh? Okay, so let's skip the Zig build system right now and just work with cargo. Oh, build dependencies, oops. Okay, so now he's pulling in C bindgen, which is, oh, you know what's nasty here? They're gonna use different LLVMs. So cross-compiling is going to be nasty because Zig kind of supports cross-compiling, but the Rust build system is kind of going to just assume that we're working on host. So probably in the Zig build system, we're going to have to take it off. The GitHub, there's no like commands in my chat because I'm a bad streamer, but there is a GitHub link in the Twitch description, and the code for everything is up there. This is the repo, and it's where we got to yesterday is all up there. But none of this inner build shit is there yet. Okay, what was I doing? I was trying to see if we generated some sort of bindings header. So where is this supposed to go? In our build rs, this is supposed to go to bindings.h. So this did, in fact, export a GUI run. Oh, fuck off. That's fine, I guess. Oh, you know what? This will be fine if once we use bindgen to generate the other bindings, this goes away, probably. And I guess this being defined twice, as long as the definitions match, isn't the end of the world. Okay. This is odd. Why the fuck is this stuff in here? Can we say, like, fuck off C++? Like, I don't want, like, C bindgen docs rs. Surely I can configure this in a way where it doesn't fucking just drop bullshit headers in there. Oh, okay. With crate, so this is using a builder. Builder with no includes. With no includes. Oh, oops. With no includes like this, maybe? Yeah. Oops. Cargo builds, what we're trying to do here. And cat bindings h. Okay. Calm down, why are you so mad at the code? Oh, dude, anchor is the fuel. Anchor's the fuel. Okay, so this is probably fine. Can I say wick without extern? I don't want it to... Yeah, it doesn't really necessarily look like there's a way to discard those imports, but that's fine. Maybe there's ways to, can I like tag stuff? Can I put things in a module and say only export stuff from a certain module? That would probably make things easier. Exclude item by name. It's not really what I want. I guess we don't need CPP compat. Let's just get that shit out of here. Okay. it's funny because even with no CPP compatibility, it's still throwing it in extra in C block. So like, what the fuck is the point? Sorry, I know you asked this earlier. There's no response. Is your neofilm available? Config available on GitHub? Nope. No, it's not. But there's nothing too crazy in there. It's basically just a telescope and language servers. Nothing else really being used there too heavily. Yeah, I don't see anything in here that's like that's like with crate. I guess I could put it in a separate crate, which is just the C defines. C bind gen only one mod. Yeah, okay. With crate. With source. With crate and name. So I guess here probably we could just punch in the file that we're using. I wonder. Could we do like with source what would it be? Source lib. So does that still work? rmbindings.h? No. Cool. Super cool. Why ls source lib? Okay, so what does this with source even mean then? Is P is a path, right? P as ref path. So this just does jack shit, I guess. Very odd. C bind gen with source. Like, what is it supposed to do? C bind gen. With parse expand. It does seem like this is supposed to work. He is also saying that sometimes it's empty. Oh no. Okay, that generated. Okay. I don't know why it didn't work last time. Okay. Now, the next thing that we want to do here is we want to split out on this side. Maybe we'll split out a source C bindings where we define this. And then here we will no, here's what we'll do. Sorry, this stays here. And then we say, this is zig bindings. So I guess for now, we'll just say this goes here. And then we say mod C bindings. How does this work? Does this all just work? Oops, cargo build, I mean. If this works, then we're chilling. So that doesn't work because we need to import CFFI. Hello, what is going on here? What is my fucking everything's just got fucked. Here we go. Okay. So this has to go over here. Why is nothing fucking what is happening? What is happening? Mod C bindings. Like, seriously, what is happening? It feels like it thinks it's some fucking buttons held down when it's not. Q all. Q all. Right? Yes, I really want to fucking write it. Q all. Get me the fuck out of here, dude. Holy. Oh my god. All right, are we back? Cargo build. Okay. Zig hello is never used here. So let's try this one. Zig hello never is not found. But now if I go into like C bindings.zig hello, is that how I use this now? Is that, I can't remember. It's private. So now if I say pub function zig hello, is that how I get this guy in there? Okay, that's looking closer. I need to be in the right folder to run the build. I guess. That was surprising. Is he working? He's thinking really hard. I wonder what he's doing with all his time. Yeah, what is happening? Seriously, my whole system just feels like shit. What is it doing? It's very strange. Very strange. Like, why? This isn't even using CPU, is just like getting fucked, I guess? Whatever. It's fine. It's fine. We'll come back to it later. Maybe it'll fix itself. So our bindings H. Seriously, dude, I'm gonna fucking lose my mind. I'm gonna lose it. So now it's not generating the bindings again. We're back to the bindings H not being generated. Oh my god, what is happening, man? Something must be just like railing my disk somewhere. Okay, so that built. Cat bindings H. Oh, god damn it, it's still leaking in there. Okay, so all of that for nothing, but it's okay. We'll just keep going. It doesn't really matter. Doesn't really matter. Okay, so here we're going to come back here, and we're going to take out the Rust functions. And from C... Let's see. From our build zig, we're going to have to include... another generated file. That's fine. We'll just we'll hard code the include for now. But we'll fix this. Fix me should come from setup rust build, and we'll shove this as a source GUI rust. In our C zig, we will include bindings.h. And now when we go back to main.zig, we shouldn't have to define this anymore. It should just come for free. And if we look at our C zig, I guess we also... Can we like... What am I doing? GUI.h. I guess here we just have to match this, and that's fine. This is already here. So now it's just where we call the Rust stuff. GUI run. This should just come from C now. And I think everything else should just kind of work. Hopefully our fucking disk is recovered, and this actually builds in some like sane amount of time. Okay, C import failed. Unexpected identifier. What's going on there? Did I forget something here? I didn't, all I added was a bindings.h. Is it this? Bindings.h unexpected identifier. Yeah, because it's generating extra C blocks, and Zig doesn't like that. So how do I, in my build Rust, he needs to fucking not do that shit. He needs to not do that shit. Which kind of means that somewhere we have to get rid of that extern thing. So we were at the cbindgen doc somewhere here, maybe? How do I get it to like not... C bind gen, no extern C, please. Dude. Oh my god. What's with C compat, like, with CP compat true, maybe? Maybe he's, like, it's the other way around? Like, what does that do? Is this even running? Yeah, it is. Okay. Can I ask this thing to, like, not spit out extern C block? Oh my god. With language. This looks promising. What do you think? What do we think? Oh, okay. This is closer. At least it put the if-def C++ in there. So now, hopefully the Zig build will work. Yeah, nice. And can we still run? Okay, we're back. We're back, baby. Okay. So now we should be able to construct this GUI callback, this GL callbacks thing. And let's just start with a hello world, which is going to be a function pointer that takes in nothing. And this is going to be provided by the Rust side. And he is going to say, when he runs, he's going to say, hey, I want to set, where does this come from? C bindings, set GL callbacks. We're going to pass in the renderer. And we're also going to pass in some GL callbacks, which I guess we'll put in static namespace. So this comes from C bindings GL callbacks. And then here we should be able to say hello world is Rust hello world. And then we should be able to say, hey, we have some function. It doesn't have to be no mangled, but it does have to be C calling convention. And he's going to take in nothing. And he's going to say or print line hello world. Okay. How broken is that? GL callbacks not found in C bindings. Oh, because this isn't generated. Fuck. We need to now generate here. We need both C bind gen and bind gen. Isn't that crazy? Okay. So create a build RS. This thing. So this comes from GUI.h. And out goes here. Boom. So here this gets put, this writes a Rust file into the target directory at bindings rs. And so in our build, our cargo toml, we need to include bind gen as a build dependency, as well as C bind gen. And what version is this? 0651. Okay. We create a build rs, and we include the generated binding. So here in our C bindings, we should do this instead of whatever the fuck we were doing. Okay, let's see how fucked that is. It's probably reasonably fucked. But we'll see. We'll see. Oh, he has got to fucking download all the shit for BindGen as well. Give him a sec. Another casual 300 dependencies. What are we at now? 500? Jesus Christ. Oh no, it's recompiling some of the EGUI stuff as well. Okay, fine. Function or item not found in cargo callbacks. 6. So does this... I mean, I just fucking copy pasted this, so... I guess this is just broken, because... BindGen, cargo callbacks, new. Tell cargo to invalidate the book crate whenever the... Whatever, we'll just delete that part for now. I don't want to deal with it. Because I just want to get something fucking working. Does it matter if it was under depths or build depths in the cargo toml? It should have been under build depths, which it was. I thought. Yep. Okay. Failed to run build command. Oh my fucking god. Okay, fucking bullshit Nix shit. Hold on. It's Rust platform BindGen hook or something. Because without that, like, BindGen will try to dynamically load libclang and stuff, and it can't find it unless Nix tells it where it is. So I think that I think that's what it's called, but I can't remember. It looks like that worked, so seems promising. Although maybe the LD library path I set might have overwritten something that's a little problematic. We'll see. Maybe? No. Fuck. GUI.h, unexpected identifier, okay. Maybe this isn't how you're supposed to do that, to be honest. Is it this way? No, it's... Right? I'm pretty sure this is it. Function pointer instruct C. Yeah, it's star thing, then other thing. At line 6. Oh, it's here. Oh, so I shouldn't put a star there. That's a really good point. Okay, so now Rust is mad because I spelled hello world wrong. And he's also mad because he's working with void pointers when he's like, that's not a void, that's a zig renderer. So here, everywhere we had C void, we're gonna swap to zig, C bindings, zig renderer. Okay. Here he wants us to write sum, so we will do that. And the GL callbacks, they should be const. So const can go here, I think. No, struct, const, struct, GL callbacks. Yeah. Who is he? Who knows, man? Who knows in this case? Expected this, found that, so in set GL callbacks, we need to look at the thing inside. And call to unsafe. Okay. Cool. So now on the zig side, we should be able to implement the set GL callbacks. So this is set GL callbacks, who takes in a zig renderer and callbacks. which is C GL callbacks, const pointer, and here we will set the callbacks to GL callbacks, and here we will just call it. Because I want to see. I want to see if that works. I guess we'll say self callbacks equal callbacks. And we'll call it directly. C import failed. Unknown type zig renderer. GUI run zig renderer star renderer at bindings.h. So this is going to be C zig renderer, I guess. I don't really like this, to be honest. There's something that feels wrong here. Because these aren't the same type. Okay. Unknown type zig renderer at rust bindings.h. So here we actually need to include GUI.h here. Which means in our cargo toml, our build rs, we need to say with include somewhere, probably. Surely they have a way to force us to include something. C bindgen docs.rs. Surely. Where are the docs? Hello? Oh, here. Which comes from the builder. Include item. So if I write this, does it generate what I want? So tell me what I want, what I really, really want. I'll tell you what I want, what I really, really want. I want it. No, fuck me. rm bindings.h. Maybe it didn't actually generate it. Cargo build. Why isn't this rerunning? Cargo rerun if changed. I don't know. Oops, cargo build, I guess is what I want here. Cat bindings.h. Yeah, it's not including what I want. Unsupported output in build script of GUI. Oh, okay, fine. C bindgen include other file. Do I have to make a wrapper on the zig side? I guess that probably makes the most sense. Oh, everything fucking blows, man. Everything blows. So we'll call this maybe, here's what we're gonna do. The GUI is we're gonna rename this to GUI common. Who's gonna have the types. Just maybe just this, to be honest. Not sure yet. I hate everything, man. This is so much more work than it should be, but it's fine. So it's really only this GL callbacks that we really need shared. Then we'll make a GUI zig. Who has this stuff? Okay. Pragma once. In our build RS, we're going to use GUI zig and include that when we generate bindings. We're going to generate our bindings.h. Okay. Now we're going to have GUI rust, and he's going to include bindings.h, but he's also going to include zig common.h or GUI common.h first. Okay, so now in our C zig, oh, I hate all of this. This is so awful. I hate it. We're going to include instead of bindings, GUI rust. And maybe that's it. Oy, 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 oy. And then the type will be defined, and then we can use it. Zig renderer not found in C bindings. Oh, because this isn't in GUI common. Fuck me. GUI rust is importing a GUI zig. Zig renderer not found in C bindings. Struct zig renderer. Not found in C bindings, because probably we have to like fucking recompile something. Oh my god, I'm gonna lose my goddamn mind. I'm gonna lose my mind. I guess if I just touch recompile this, it'll fix itself. Okay, GL callbacks not found in C bindings. Include GUI common.h. I feel like all of this, I feel like I've over-engineered something. I hate it. I hate it all. Okay. We're going, here's what, we're going back. We're undoing all of this work. Because this fucking sucks. This is terrible. I thought that it would be better to share a common header, but it's very, very clearly not. But this is the only thing that we need to find in multiple places. So what we're going to do is we're going to say, fuck all this noise. Fuck it all. Burn it to the ground. So, fuck you. Fuck you. And we're going to go back to fucking hand defining this shit. I guess. Does that make sense? Yeah, because it's just so awful. All of this is fucking awful. So we're gonna go back into our. I guess we're gonna keep in the build RS. This is gonna come from GUI common, so that we have the common fucking type. But that's it. Everything else, get the fuck out of here. Get the fuck out. Oh my god! And then I'm back in this like fucking fucked up state. Okay. So now, in librs, we have to go back into here and define our set GL callback. So we're going to define these by hand. Which was just set GL callbacks and zig hello. So we're going to say function set GL callbacks, which is going to take in a renderer and callbacks, which is a const C bindings GL callbacks, and function zig hello, which took in renderer. All of this C bindings zig renderer. This is going back to C void. Fuck. Because fuck that shit. And let's see what happens. He's got to think again. It's a hard life over here. I wonder why it has to recompile everything like that. I actually don't understand. GL callback's not found in C bindings? Why the fuck not? GUI common GL callbacks. So now what? Oh, probably something. Oh, we didn't fucking output the fucking. We forgot to write the bindings down. We forgot. We forgot. Where's the bind gen guide? We lost it. Here. It was this. We forgot this stuff. Oops. Didn't mean to delete you. Come back, please. Thank you. Oh, boy. Oh, boy. Oh, boy. What is it doing, man? Oh, man. I'm gonna lose my mind. Hurry the fuck up, computer. Please. All right. Okay. Okay. So now GUI Rust doesn't exist, but that's okay. So C zig. We're only going to import GUI common. And then in our main, we still define set GUI callbacks and zig hello, but we just use these types on ourselves. And hopefully this works. No, fuck, of course. Why would it work? GUI common not found. GUI common. This is in source GUI. So we need to add to our build zig a include path to source GUI here. Any videos you're set up? Nope. But setup's just, I don't know. It's just NeoVim, Tmux. I don't know. I'm not too worried about it. Okay, so cannot call optional types. We're getting close now. So here we should be able to dereference this guy and then call him. Wait. Callbacks. This has to be a C pointer, actually. But then I think it should be fine. We have to be a little bit careful here. Cannot call optional type. Where is the optional coming from? Oh, do I have to dereference this as well? Maybe? Is that what it's complaining about? Missing struct field callbacks. Oh, we're getting so much closer. We're getting so much closer. So this is actually going to be initially nulled, and then we're going to say when we make this guy in main that his callbacks is equal to null. Okay. Root file has no GUI run. So we need to define this ourselves now because we got fucking sick of the shit. So GUI run is an extern C GUI function GUI run that takes in a renderer and returns nothing. And I guess I don't think we have to write C pointer here, but maybe it's a little safer to. Root file C. So right, GUI run doesn't exist. So C GUI run is just GUI run again. And C pointers cannot point to non-C ABI compatible type main zig render. Okay. So I guess we'll just say it's a normal pointer, and hopefully everything still works. Okay. Okay, so I think that hello world did get printed. After all of that, hello world from Rust callback after we set the callbacks. Thank fucking God. Let's just see. Hello world from Rust callback after we set the callbacks. Thank fucking God. Woo! Okay. That really sucked the life out of me, man. But okay, so where did we end up? We tried using bindgen and to generate Rust to C, a C header from the Rust code, and bindgen to generate Rust code from the C header. And then eventually we just said, fuck this. This is too hard. We'll write them ourselves. And the only thing that we're using bindgen for now is sharing the type definition of this structure. So, because what's going to end up happening now is we're going to end up adding a bunch of different like OpenGL functions to this guy, and trying to sync them between the two would have just fucking blown. So, that's good enough for now. I think I'm gonna call it there because I got really fucking pissed. And also we're at 2.5 hours. So I should have just said that. I didn't have to say I'm pissed. We're gonna call it here because we're at the 2.5 hour mark, and we generally try to stream for around 2 hours. Otherwise, it's too long for YouTube, in my opinion. 2 hours is around the limit of what I would be willing to watch, which is kind of why we're doing this in the first place. So, thanks for watching, guys. If you like what you saw, I stream most days at around 2 o'clock Pacific time for around 2 hours. There's YouTube and GitHub links in the Twitch description, where on YouTube you will see all of our previous projects chunked up into playlists, and the GitHub has, things around there. So you'll see QR code decoder, zlib, inzig, git GUI, TV tracker, Linux webcam, terminal emulator, file system, neural network, 3D engine, operating system. There's lots of stuff in there if you want to go check it out. If not, no big deal. If you're watching on YouTube, there should be a Twitch link in the YouTube description. I think that's all the plugging we gotta do. I guess, subscribe, Prime, Twitch Prime, all that good stuff. YouTube viewers, goodbye, and Twitch viewers, let's figure out who to raid.